Yeah, let's dive into the approach we've defined. So we came up with a 5-step approach to assess price sensitivity of your products. So we apply this approach after we've set the scope for the product, and you can use the previous slide Roy explained for selecting the articles which could be applicable for price optimization. Yeah, we have 5 steps, and in the next slides I will get you to these 5 steps by examples, what we will do during these 5 steps. So step 1 is that we select the sensitivity drivers based upon customer input. So similar to the situation where Roy just explained what drivers and what sensitivity drivers drive beer, we do the same actually for your product. So we come up with stakeholders in your organization to have a discussion with each other what drives the price sensitivity of your product assortment. And we usually do this with a couple of products where we take as an example and we ask different stakeholders in the organization, why is this product so sensitive? And then you can come up with a long list of drivers as a brainstorm. And what we do with this long list is that we ask the stakeholders, what is your expert judgment? So what is the relative weight and relevance you give to each driver? And it gives us a first input of all the experience in the company to assess later the sensitivity to the product. So this is more qualitative approach, but it really helps also to get a consensus, but also to really understand what is also most important to develop the model and to look for data sources. If we go to the next step, if we have the data sources, we are going to test the assumptions and also test the relevance of the expert judgment. So here we can test not only the correlations between drivers, as Roy explained, there could be relation between the product lifecycle and competition. That's something that comes up with a correlation matrix that is shown right here. So this correlation matrix, you see that the red scores, the darker the red, the higher the correlation. So the higher there is a relation between drivers. So in this example, you see there's a big relation between the price change frequency and the quantity sold, and also between the price level and the price and the price change frequency and the number of competitors. So these are relations, and you want to get the confirmation from the company that you also see this in the beginning, during the sensitivity driver interviews. So that's something to validate. In the next step, what we are doing on the next slide is that we are going to develop the model. And what you usually see during the correlation matrix is that some drivers could overlap, so that you come with a filtering, a shorter list of drivers which are in the core model. In this example, we have 6 drivers that we've developed the core model upon. And then what you get is actually a formula. It looks a bit complex, but it is actually a formula where each driver gets a certain coefficient, and this coefficient is based upon the regression, and each coefficient also gets a beta and an input. And the total sensitivity score is based upon the input of each driver multiplied by the coefficient. And that's a logical step to define price sensitivity and the mathematical formula of the drivers we've defined in the beginning. This is more the technical part. And what we're actually doing in the next step is that we put together the machine learning and the expert judgment. So as you've maybe attended previous webinars, or if you're a customer at SYMSON, you're probably familiar with our vision of hyperlearning. And this is where we combine machine learning together with, we call it human learning or expert learning. So this is where the things come together. So the coefficients of the machine learning, we combine with the expert judgment. And the combination, it could be 50-50% combination. That will be the total sensitivity impact score. Especially with products where we have less data for, this gives us a lot of valuable input to combine it, to have one consensus for the technology, but also from the company to measure the total sensitivity. And later in the process, when there's more data involved, we can put higher weight to the machine learning if that's preferred. So what we do then is that we just run the model across all products you selected for the scope of the sensitivity pricing algorithm, and then you get an output. So your whole assortment can get assessed for what is the price sensitivity score. In this case, it's a plot on the products that are sold on Amazon, and you see here on the left side the products below, or sorry, above 0 are the least sensitive products. And on the total right side, you see the products that have the lowest score, so -4, -5, and they have the highest price sensitivity. So minus means that it's very sensitive, and plus means that it's less sensitive. And you can create a plot like this. That's what we're doing. And all products get a price sensitivity score. And on the next slide, you see an example. So we validate the coefficients, but also the outcomes based upon a lot of products to really understand how the model behaves and how it comes to the logic of the sensitivity. So in this case, this product is sensitive. It has a minus score, and you see it's a plate, and this plate that has a price. It has a certain order in the basket size. It is an product attribute that is fast mover or slow mover. It has an A brand or private label. It has had a couple of price changes in the past, and it has a couple of competitors in the market. And each of these drivers, they have a certain coefficient, and the input on the coefficient is determined by the categorization of the data. That is also a very important step in the process. I'm not going too specific in this because it's a bit more technical, but the sum of the price sensitivity score is actually the sum of all the input times the coefficient, and that gives you the end score of the price sensitivity with the formula we've developed. So with our tool, with our model, we can assess all products based upon price sensitivity, but our lessons learned, we dive into that later. It's also that you make the interpretation of these products explainable to the stakeholders in the organization, and also how the model came to this price sensitivity score. So in our interface, we provide you with insights. Each product you've uploaded into SYMSON could get a price sensitivity score, and we offer you also a heat map as by the charts to explain and to make clear what are the main drivers for this product, and in this case, what leads to the price sensitivity. And what's always a nice exercise to do with the company is to visualize the top 5 most sensitive products and the top 5 least sensitive products. And what you see here is on the vertical axis, you see your product codes, and on the horizontal axis, you see the drivers. And it gives a nice overview of the contradiction between the most sensitives and the least sensitives, where you see they're behaving totally different. The greens means that there's a positive relation, and the red means that there's a clear negative relation. And this makes it very powerful to understand the logic of the model, and also to have the confirmation from the company to understand the logic, and to also confirm that they also see this price sensitiveness in the products and in the sales. An important step also in the whole development is that you plot the model and assess the right price sensitivity scores on the right dimension. So also in our previous webinar on price sensitivity, and also in general in your price process, it could be that you have different customer behavior in different markets, in different channels, or in different countries. So also with price sensitivity, it's good to be aware, if you already know that beforehand, if you have a different price sensitivity per channel, that you also plot the model on a different dimension, in this case, the channel. So what you see here, one of the projects we've run for our customers, is that we see for the same assortment, for the same portfolio, we have a totally different price sensitivity based on the platform. So you see here, Amazon as a channel has way more price sensitive customers than Otto. Otto is a German marketplace, just like Amazon, only a little bit smaller. But you see here that there's a clear difference, and that's good to realize, because you cannot run the same experiment based upon these insights. So when we have all price sensitivity scores from products, the next step is, of course, that you are going to put this into practice, and that you are going to execute based upon these price sensitivity scores. And as I already showed in one of the previous slides, that the minus scores of the products have a very sensitive outcome, and the plus scores have an insensitive outcome. And that's also what we are doing. We make buckets of groups, buckets of products, and then we ask to the company, okay, what level of price change would you like to experiment with? And for the most price sensitive products, we choose for a discount. This can be -4%, can be -2%, depending on how aggressive the company wants to act based upon this price sensitivity. And for the insensitive products, we choose for a markup. And also this markup is based upon how aggressive would you have this experiment. It's really important to measure the change in volume after the experiment, but to also measure the sensitivity and to continuously optimize this based upon new data. So this is a 5-step approach, how we can come from actually no model to a model that can predict the price sensitivity of each product. And as I already said, is a continuous approach. So it actually doesn't end after step 5, but we get smarter also after these experiments. So this is a continuous approach and a way of, we call it hyperlearning your company. The next chapter is about how to implement it and to set up a good experiment. So as already said, we divide products, all the products that has sensitivity score, into buckets. And in this case, we have 8 different buckets. And these buckets are connected to a price change. So as already said, in this case, the very sensitive buckets get the highest discount, and the very insensitive bucket gets the highest markup. And in between, we have some other percentages to test also the bit more moderate scores. So we split that into groups. And we also usually have a control group, and this control group could be another channel, could be a split in customers, or could be a split in products, depending on the environment of what is possible for the specific customer. So this could be an outcome for B2B and B2C. So what we do for B2B companies is those buckets could be 8 or 16 buckets. We divide all the products of the assortment, which is applicable for sensitivity, into different buckets. And we define what could be a better net price based upon the price sensitivity. So we take the current net price and we say, okay, it should be increased or decreased based upon the sensitivity. And of course, the most sensitive products get a discount, and the least sensitive products get a markup. And it's also really interesting to see also for the company for which products the willingness to pay is higher than for others. So for which products can we let go a little bit the cost, and can we price more on the price sensitivity of each product. For B2C, promo management is a big thing. So therefore, price sensitivity can be used for promos. A very sensitive group of products can be used for effective promos. And for the very insensitive products, you could leave margin or you could leave money on the table if you're doing these kind of products into promotion, because they could be less effective. Of course, you can experiment with it, but based upon data, we can give you a suggestion and a recommendation which products are really beneficial for promotions to drive traffic or to increase revenue or to increase the total share of wallet of a customer.